Hello everyone, this is for pre-calculus. It's Introduction to Transformations. Where I want to start you guys off is looking at writing the equations for a line in the point slope form. So if this is the information you're given, you guys would write y minus 3 equals half x minus 2. This would be, whoops, I don't know, I got a parenthesis going on. Don't know what I was thinking. Minus 4 is equal to 2/3 x plus 2. So when you're looking at this, remember that that's going to be opposite. If you want me to slow it down, y minus equals x minus, and now you're going to fill the information in. The 4 is going to go right here. The 2/3 is just going to fill in right there. And the minus 2 is going to fill in right here. So that turns into plus. Right? Remember to read the coordinate out. You're going to read this opposite, so that would be 4, and you're going to read this opposite. So that's going to be -2. So writing it again, sorry if this is, you've got this down 2 assignments ago, and going over this is like watching paint dry. I apologize. It's not my intent. It's wanting to make sure you guys are totally fluent with it. So it'd be y minus a -2, so it'd be plus 2. X minus a -1, so it's plus 1. And there would be the equations in point slope form. And again, you read the point out by taking the opposite of this and the opposite of that. If you were to go and graph it, we'll talk about that on, I believe, this page right here. How do you read out the coordinate in this given equation so you can graph it? Just like what I've been stressing on the previous page, you're going to read both of these opposite. So if I asked you to graph this, you'd have the coordinate -2, -3. So -2, -3. And from that point, you can do a slope of -1/2. Down 1/2. Down 1/2. And so this would be that line. Right? This one would be 2, -4. So 2, -4 with the -2/3. So down 1, 2, 1, 2, 3. Thanks. So then this would be that line. Yeah, it doesn't look like much of a line, but you understand what I'm trying desperately to do. So the starting point would be -5, 7. So -5, 7. And the slope is 1/5, so up 1/5. So then this would be your line. Okay. So I think you've got the hang of it. And if you guys wanted to be able to type this in your calculator, what would you need to do to it so you could type it in your calculator? Well, you'd have to get rid of this y value on the other side. So you'd have y is equal to -3, x minus 1, plus 2. So in other words, I'd add a 7 over, plus 7. I'd subtract a 4 over, minus 4. I'd subtract a 3 over. Now looking at these now, do you continue to read both the x and the y value opposite? And the answer is no. The only one that you're going to read opposite is the x value. When it's written so you can type it in your calculator, you've already taken the opposite of this y value to move it to the other side. You've already subtracted the 3 over. So you've already done the opposite of what's written there. You've subtracted the 4 to the other side. You've done the opposite. So when it's written so you can type it in your calculator, it's only what's in the parenthesis that you're going to read opposite. This one, then you're going to read the same. Okay? So, looking at this, how do you read the coordinate? Well, like we just went through on the previous page. This one's read opposite. This one's read the same. Opposite, same. Opposite, same. Opposite, -1, same, -2. So, what is the generic formula for a point slope form if you're going to type it in your graphing calculator? So it would be y is equal to, let's start out here. Y minus y1 is equal to m, x minus x1. If I move this over, I get y is equal to m, x minus x1, plus y sub 1. All right, that would be the generic form, a point slope form, if you're going to type it in your calculator. This one you read opposite, this one you read the same. All right, these things you need to memorize what they are. This one's a parabola. This one's a hyperbola. This one's an inverse square. And it's supposed to be a square. I'm just too lazy to write the word. This is the absolute value graph. And this one is a square root. I'll just write the symbol for an interest of time. The generic equation for this is going to be y is equal to ax minus h squared plus k. This one is y is equal to ax minus h plus k. This one, y is equal to ax minus h squared plus k. Y is equal to ax minus h plus k. Y is equal to a square root x minus h plus k. And just like you guys got used to reading the equation for a line, y is equal to slope x minus h plus k. If I wrote it that way, this would be your x sub 1, that would be your y sub 1. You read this one opposite, that one the same. It's no different here. Your coordinate is hk is going to be the lowest most point if your parabola is opening up. If your parabola is opening down, hk is going to be your highest most point. This is read opposite, this is read the same. This is read opposite, that's read the same. Opposite, same, opposite, same, opposite, same. Just like you did with a line. That's the whole idea. Can you guys transfer the knowledge you have for a line to all other graphs that I'm going to give you? Yeah, you can. It's not that bad. Okay, now let me give you guys a little more information as we go about this. All right, for a parabola, if I'm looking for you to sketch the graph, the parabola is not that bad. All right, let's look at it. You're going to read the vertex. That's what that point is, the vertex. It's supposed to be an E. Vertex is going to be read 6, negative 8. It's supposed to be a prime. So 6 over, 8 down. Your parabola is opening up because A is positive. When A is greater than 0, your parabola is opening up. When A is less than 0, your parabola is opening down. And I'm just looking for you to sketch it. So, and your parabola is, there it is. Let's find another parabola, this one. Your vertex is negative 6, positive 8. A is positive, so it's opening up. So negative 6, positive 8, and it's opening up. So there it would be. All right, see if we got any more parabolas in here. Nope, no more parabolas. Let's try the absolute value graphs. Those ones are pretty straightforward. Absolute value graph is just a V. You're going to read that as 6, 8 is the coordinate. 6 over, 8 up. A is negative. It's going to treat it just like a parabola. So your V is going to be opening down. Your absolute value graph is opening down. Let's see if we've got some more absolute value graphs in here. Yep, there's one there. The corner, that point of where it starts, opposite, 6, same, negative 8. So 6 over, 8 down. The value of A is negative, so it's opening down. That's a quick sketch of it. There are no other absolute value graphs. Let's try the square root graph. No square roots on that level. Here's one here. I'm trying to trick you a little bit here. That value of A is a quarter. So if you want to think of it as y is equal to a quarter, how about x minus 0 plus 6? So the graph is starting. At 0, 6. A is positive, so it's the upper half of a sideways parabola. If A was negative, then it would be the lower half. But it's not. A is positive, so it's the upper half. Alright, so it's the upper half. Here's another one. How about a plus 0 out here? So if you want me to help you rewrite it, so you got y is equal to a quarter. Oops. I put a parenthesis, I need a root. Square root x plus 6 plus 0. So it's starting at negative 6, 0. Negative 6, 0. So it's starting right there. A is positive, so it's the upper half of a sideways parabola. Once again, if A was negative, then starting there, starting at the same place, it'd be the lower half of a sideways parabola if A was less than 0. All right. Now the two that are left are hyperbolas and inverse squares. Both of these are going to have asymptotes. So if you want, let me draw you one first. Let's say I gave you y is equal to 3 over x minus 2 plus 7. You're going to have a vertical okay, here's the parent graph. The parent graph has got a piece here and a piece here. They're both included in the main graph. It's centered at 0, 0, and you have a horizontal asymptote here and a vertical asymptote there. This has been scooted. That center point is now at 2, 7. So it's been pushed 2 units right, 7 units up. So 2 units right, 1, 2, 3, 4, 5, 6, 7 units up. That's the center point. So you're going to have a vertical asymptote running here and a horizontal asymptote running there. A is positive, so it's the graph sitting in the positive orientation, which is this orientation right here. If this was a negative 3, then it'd be sitting in the negative orientation, which is sitting here and here. So you guys find your center point by reading a coordinate out, and then draw your vertical asymptote and your horizontal asymptote through it, and this is A is greater than 0. If it was here, then that's going to be A is less than 0. Okay, let's go back to, there we go. Okay, let's see if we can sketch some of these. All right, this one, if I draw it, that was the hyperbolas. So let me do the hyperbola. So that would be this one. Your value of A is a half. So A is positive. So if I rewrite this as y is equal to 1 over 2 x minus 0 plus 6, your center point hasn't been moved left or right, but it's been lifted 6 units. So your center point is up 6 units. So your horizontal asymptote that used to be here is now pushed 6 units up. Your vertical asymptote is still right here. And A is positive a half, so your hyperbola is sitting here and here. All right, let's find another one. Here we go. If I put plus 0 out here, it's been kicked 6 units right, because you read this opposite, and no units up to down. So your vertical asymptote is now here, and your horizontal asymptote hasn't moved. Your horizontal asymptote is still there. A is positive, so it's going to sit in the it's going to sit in the positive orientation. So we're sitting here, and oops, got a little close. All right, there we go. Now, let's go inverse square. Inverse squares will be very similar to this. So if I do the positive one just like I did it before, but this time there's going to be a square on the bottom. You're going to have a vertical asymptote at the center point and a horizontal asymptote at the center point. So 2 units over, the same vertical asymptote as with the hyperbola, and the same horizontal asymptote. So the asymptote, finding the asymptotes work the same in either hyperbola or inverse square. Now what's different is the inverse square graph is either both pieces are up or both pieces are down. This is when A is positive, this is when A is negative. So A is positive, there's my asymptotes, just draw it in. Okay, that's not a right angle, it's a curve. I'm making it look kind of right angle-ish, it's not my intent. Okay, why did I draw that one for this one? Okay, that's this one, that's when A is negative. I am so sorry, you guys. Alright, let's try and be a little better about this if I make it positive. Y is equal to positive 3, x minus 2 squared plus 7. Alright, vertical asymptote 2 units over, 7 units up, and A was positive, so it's going to be sitting in the positive orientation. Okay, this is going more vertical as it goes up. It doesn't cross the asymptotes, it does that one. Okay, so let's come back. This one hasn't been moved left or right, but it's been raised 6 units. 6 units up. So you have a horizontal asymptote here, vertical asymptote is there. A is positive, so it's sitting in the positive orientation. So it's here and here. Let's try this one. A is still positive, but now it's sitting 6 units right. So you have a vertical asymptote over here. This is still the horizontal asymptote, sitting in the positive orientation, so it's sitting here and here. Sorry, I made that look more right angle than it should, and it shouldn't touch the horizontal asymptote. Okay, last two things. Write the equation for this graph, for the following two graphs. I'm intending these to be whole numbers, as I'm not intending them to be fractional or anything like that. So like for that starting point, I'm intending it to start at that whole number. I'm intending the vertical asymptote and the horizontal asymptote to be on those whole numbers. All right. So it's 1, 2, 3, 4, 5 units over. So 5 units over. And 1, 2, 3, 4, 5, 6, 7, 8. Now, understand this is the limit of the ability of the calculator. It looks like it's drawing it right on 8. It actually isn't, and that's just experience of knowing how the graph is going to be doing it. I'm not going to gig you on a test or a quiz if you're off by a single number. If you're off by several numbers, yes, I'll mark it wrong, but off by one number, I'm not going to be crabby about it. Okay, so that's 8 units up. It's an inverse square graph, so it's going to look like A x minus h squared plus k. So far, you know y is equal to, it's been kicked 5 units right, so I have to do it opposite, same number, 8. Now, the number you choose for the top, how about we just keep it simple? How about this, keep it 1? You don't know the value, oops, -1. You don't know the value of A other than it's negative. You don't know the size of it. Is it -1 or -11? You don't have any information to tell you. So if we just want to be, how about consistent and not get too crazy about it, that's just, how about just keep it either a +1 or a -1. I'm not interested right now in you guys being able to solve for what that number is. I'm just looking, can you recognize the pattern and can you reverse engineer what these numbers are telling you? That's all I'm looking to do. I'm not looking for you guys to actually calculate what the value of A is. That's a different scenario, a different type of equations I'm looking for you to do. All right, so here. You know it's going to be the square root graph. You know it's the positive version of the square root graph because it's the upper half. If it was the lower half, then you would know it was negative. Okay, so here goes. I don't know why I put an arrow on the end of that. Got kind of crazy, I guess. So y is equal to, it looks like 1, 2, 3, 4, 5, 6, 7, 8 units left. So x minus 8. And then, how about, what do you want to say, 2 units down? It's the positive upper half, so just leaving a 1 there is just fine for me. All right, I think that's it for it. Thank you guys for your time.